Hello and welcome to today's lesson on resultant forces. In today's lesson, we will begin by defining resultant forces and learn how to calculate them from free body diagrams. We will then consolidate our new knowledge with some worked examples. Let's get started. When you see a diagram with several arrows pointing in different directions, each arrow represents a force acting on an object. These forces might be pushing or pulling the object in various ways. Firstly, we can simplify the situation by drawing a free body diagram, which we learnt about in our previous lesson. To make it easier to understand what's happening, we can simplify our diagram by combining these forces into what we call a resultant force.
So, what is a resultant force?
The resultant force is a single force that has the same effect as all the individual forces acting on the object combined. This touches on a core idea. When multiple forces act on an object, they can either work together or oppose each other. If forces act in the same direction, they add up to give a larger resultant force. If forces are acting in opposite directions, they can subtract from each other, resulting in a smaller resultant force, or possibly even a zero resultant force. Crucially, it is the resultant force which determines how an object's motion changes. For instance, if a large resultant force is acting on an object, it might accelerate quickly. Conversely, if the resultant force is small or zero, there might be little to no change in the object's motion. Let's consider a few simplified examples to understand this concept better. In the first free body diagram, we see two arrows. One has a magnitude of 3n and the other 5n. Both arrows point to the right. Here, the forces work together. The two forces add up, giving a larger resultant force. Therefore, the resultant force equals 3n plus 5n, which gives us 8n to the right. In the second diagram, we have two arrows again. One arrow has a magnitude of 3n to the left, and another has a magnitude of 5n to the right. Here, the forces oppose each other. We need to subtract the smaller force from the larger force to find the resultant force. Therefore, the resultant force is 5n minus 3n equals 2n to the right. Finally, in the third diagram, the two arrows are equal in magnitude, each being 5n, but they point in opposite directions. Here we subtract the forces. Therefore, the resultant force is 5n minus 5n equals 0n. Since the forces are balanced, the resultant force is 0. This means there is no change in the object's motion. In today's lesson, we delved into the concept of resultant forces. We began by understanding that each arrow in a diagram represents a force acting on an object, which can be simplified into a single resultant force. This resultant force is the combined effect of all the individual forces acting on the object. We learned that forces acting in the same direction add up, creating a larger resultant force, while forces acting in opposite directions subtract from each other, potentially leading to a smaller or zero resultant force. Ultimately, the resultant force determines how an object's motion will change. A larger resultant force can lead to quick acceleration, while a smaller or zero resultant force can mean little to no change in motion. Watch the rest of the GCSE Physics course at Sophos Education